Hi and welcome to this Junior Cycle Higher Level Maths Revision video. In this video we're going to be revising sets. So as part of this revision we're going to look at sets notation, Venn diagrams, rules for generating sets, subsets, properties of sets and some problem solving involving sets. Now, because this is a higher level video, we will look at both 2 sets within the Venn diagram and 3. So here we have a Venn diagram. This is named after John Venn. We have a circle representing the set A and the circle representing set B. Our sets are always named with a capital letter. When we're dealing with real life problems, we often use a letter that makes sense. So for example, if we were talking about sports and we had basketball and football, we would use the letters B and F. We often see with Venn diagrams the universal set drawn. The universal set is a rectangle with a U written outside of it, and that denotes everything that we're talking about. So for example, the universal set might be your class, and the underlying sets A and B. A might be students who play basketball, B might be students who play football. There will still be students who don't play either that are still part of the class, and the universal set helps us to capture this. On page 23 of your log tables, you'll find these symbols. Now, there's one symbol here that's not relevant, all the rest are. This can be helpful when we're doing any kind of question related to our Venn diagrams. You are probably aware of most of these symbols already. We have intersection, union, set difference, subset, element, and null set. I'm going to show you how these look when we deal with Venn diagrams, how we can use them, and I'm going to show you some other notation that's not in the log tables. So here is intersection. This you can see our universal set, the rectangle, set A and set B. A intersection B is where the circles intersect, where they overlap, and that means what is in A and B. Here we have union. So we have A union B. Notice how everything is shaded. This is stated as A or B. This might seem a little bit basic, however, it's something that students do tend to get wrong. This is set A. Set A is the full circle. Often students leave out the intersection, which is incorrect. So set A is the full circle of A. Set difference is less or take away. Remember, the word difference in maths means to subtract. So it's B take away A. So if you have the whole circle B and you take away anything that was from circle A, what we're left with is the shaded bit here. Here we have a subset. So B is a subset of A, which means it's a smaller set within A. The symbol for subset is like a C. I think of this as B is contained in A. Here we have complement, so LE. So where you might complement somebody, you have something that they don't, and vice versa. Notice that this is not in the log tables. A complement, it has just a little dash up like this, and it means everything that's not in A. So it's the opposite of A. So notice how A is the only thing that's not shaded. When we talk about elements, we're talking about what's inside the set. So here is set X, and A is an element of X. So A is something that is in X. So that's our symbol, AEX, which is A is an element of X. And then F is not an element of X. So F is not an element of X. It does not appear in the circle of X. Cardinal number is another thing that's not in your log tables, but it's very important that you understand it and can use it. Cardinal number of X is 5. So what this actually means is the number of elements in X. So when you see this symbol, which is the hash tag or pound symbol. It is the number of elements. Let's look at an example. From the diagram on the right, write down the cardinal number of A. So how many elements are in A? Now remember, A is the full circle. So if you said 4, you're not correct. It's actually 7. We're looking at all elements that are within the full bubble of A. So the cardinal number of A is 7. The cardinal number of B is 6. The cardinal number of A intersection B, intersection is this piece in here, that's 3. And the cardinal number of A union B is everything here. So we have 10 altogether. Notice that the cardinal number of A is 7, the cardinal number of B is 6, but the cardinal number of A union B is only 10. And the reason for that is because there's 3 in the middle that we don't want to double count. Example 2, using Venn diagrams. In the given Venn diagram, each dot represents an element. So we can often see this in a question if we don't want to clog it up with actual numbers or letters or elements. So they use the dot, which we usually see beside the element, to show that there is an element. Now, we won't ever be able to list the elements because we don't know what they are. However, we will be able to answer these questions, which are all about the cardinal number. How many elements? So it asks us to write down how many elements are in A. So A is the full circle of A. So it's everything that we've highlighted here. And if we count them, there are 7 elements. B then, what is the cardinal number of B? B is the whole circle of B. So again, counting these, we have 7. Our third is the cardinal number of U, where U stands for the universal set. So that's asking how many elements are in this full box. So if we count them up, we'll get that there are 14 in total. The fourth question asks us for the cardinal number of A union B. So A union B is A and B combined. So when we add these together, we get 11. The fifth question asks us for the cardinal number of A intersection B, which is where A and B intersect, where they overlap. And in there are 3. And the last question, which is probably the trickiest of all, asks us for the cardinal number of A union B complement. So remember, complement is the opposite. So what we're going to do is we're going to look at A union B, which I'm doing in black here, and we want the opposite to that. So what's not in A union B, which means we're looking at everything that I haven't highlighted in, which is everything around the edges, which means there are 3 elements that are not in A union B. So example 3, here we're now given the elements again. We have our universal set. Within that there is set A and set B, and there are some elements that are not in A or B. We are asked to list the elements. It's really important that you understand the difference in these questions. Here we're asked to list the elements, so tell them what is in there. So this backslash here means less or set difference. What we mean by that is take away. So if I have A and I take away B, so I get rid of anything that's in B, I can do that in a different color. So get rid of B. The bit that's left highlighted yellow, that's what we want. So that bit there, we have the elements A, C, and E. If we do B, take away A. So here is all of B. We take away A, so we get rid of these bits in the middle. And what we're left with is F, G, and H. If we look at the whole set, so the universal set, and then take away A. So we have the bit on the outside, we have this bit here, and these bits. And we want to take away anything A. So I get rid of that highlight there, and everything that's left highlighted is what we want. So that is F, G, H, I, and J. The last question is the universal set. Take away A intersection B. So again, let's highlight the whole universal set. That's what we've started with. And we take away A intersection B, which is this part here. And what we're left with is A, C, E, F, G, H, I, and J. Example 4, completing a Venn diagram. So we're going to do this with a 2-set Venn diagram. So we've set A and set B. We also have the universal set, which they've given us. So the important thing to note is that we always start filling in a Venn diagram from the center, so from A intersection B. So we need to figure out what the set A and B have in common. So there's a 3 in common and there's a 5 in common. So we'll fill those in first. Because they're elements, they will go into the center with a dot beside them. That dot indicates that they are an element. If that dot's not there, it means something else, and we'll come to that later in the video. So I like to cross these off when I use them. That way I won't get confused. We have 3 and 5. They're only entered once because remember that intersection represents where we have elements that are in both set A and set B. I then fill in the rest of A. There's a 1, 2, and 6 left. B, 7, 9, and 11. Now we've used all of these. We need to look at the universal set. So the universal set are the numbers 1 to 12. So we need to make sure that we've included all the numbers 1 to 12. So we have 1, 2, 3, 4. Oh, I actually left out my 4. This is, even when you're crossing it off, be careful. So actually there's a 4 that belongs in here, in A. So we have 1 included, 2, 3, 4, 5, 6, 7, 8. Now, 8 is not in set A or set B, but it is in our universal set, so it's placed out here. 9 is in set B. There is no 10, so we'll include 10 here. 11 is there, and finally 12. So just double check to make sure there are 12 elements in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Example 5. Let's look at a 3-set Venn diagram. So in this, we have set A, set B, and set C. So 3-set Venn diagrams create a lot more areas, so they can be a little bit more complex to work with. So the first question we're asked is list the elements of A intersection B intersection C. So where all 3 intersect, which is this very middle bit here. So the elements are 2 and 8. The next thing we're asked to do is A, take away or less B union C. So let's start with A. We're going to highlight all of A. I like to highlight all the sections separately. It just helps me with rubbing out. B union C. So we take away, I'm going to rub out anything that's in B and anything that's in C. That leaves us with 3 and 7. The next thing we are asked to do is C, take away A union B. So here is C all highlighted, and then we take away everything that's in A or B. So that leaves us with 12 and 13. The next thing we're asked is A intersection B. So where does the circle A intersect with B? Now, it can be quite hard with that third circle, but C is not included, well, not included. C is not even spoken about in this. So ignore C completely. We have A, we have B, and here is where they intersect. So think back to your last few 2-set Venn diagrams. We just had A and B, and that's what our intersection looked like. So that is 1, 2, and 8. The 5th part here A intersection B, take away C. So let's do A intersection B, which we have just done. So we're there. Now we take away anything that was in set C. So there's A intersection B. We now take away C and we're left with just 1. The last one is A union B union C complement. So for this, I like to colour in a dark colour the thing that we effectively don't want, because this is A union B union C complement, which means not A union B union C. So union means all together. So there's A union B union C. So it's everything that's not that. So everything we can still see, which ends up being these two, which is 14 and 15. Example 6, describing a set. So in the diagram, A is equal to students who like apples and B are students who like bananas. Describe the set of students that is A union B. So that means students who like apples or like bananas. A less B is the set of students who like apples but don't like bananas, or an easier way to say this are the set of students who only like apples. Finally, we're asked to shade this region. Now, I'm able to do this a little bit easier because of the pen, but this will help you follow along. So we've A union B, which is this bit, and this bit. Take away, so I've done this, take away, so less, A take away B. So A take away B is this bit here, and that's what we want to take away from my original shading. So where there's double shading, we're going to take this away, and this is what we're left with. Example 7, subsets. So subsets are sets that are contained within sets. So we've been given this set A here, which has the elements 3, 4, and 5. They want us to list all the subsets with one element only, and then list all the subsets with 2 elements only. Now, it's important to note that the number of subsets any set has can be calculated by doing 2 to the power of n, where n is the number of elements in that set. So for example, this set A has 2 to the power of 3. Now 3, because there are 3 elements, 2 to the power of 3 is 8. So then list all the other possible subsets. Each set has 2 improper subsets, which are the self itself and the null set, which are these 2. And now we can see that we have 3, 6 already answered in part I and II. Now we have 2 more. Now we have our full 8. The remaining subsets are known as the proper subsets. So what we answered in part I and II, those 6 subsets are known as the proper subsets. Example 8, rule for generating sets. So this kind of question is a little bit different. We're really getting into very mathematical notation. It's not something we've seen on the junior cert exams. I think that the way that the junior cycle has been structured, it's going to be more real life situations than formal mathematical notation, but it's still good to see this. So it asks us to list the elements in C intersection D if C equals. Now, what this thing is telling us is what is in the set. So X is the elements, and X is between -4 and 9, where -4 is not included, but 9 is, and X is an element of Z, means that X is an integer, so positive or negative whole numbers. We then have a very similar rule here for D. For D, they tell us that the elements are between -2 and 2. -2 is included, 2 is not included, and x is again an element of z. It is an integer. So we want to work out what is the intersection. Now, you don't have to use a Venn diagram, but I think it's nice for us to visually see what this means. So we have C here and D here. I haven't bothered with a universal set. So the first thing I'm going to do is figure out what's actually in the set C and in set D. So C -4 is not included. So then the next number will be -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now you get a sense why they use the rule rather than listing these all out. D is a little bit smaller. -2 is included. -1, 0, 1, and 2 is not included. So now we need to figure out what is common. So what's common? There's a 2 in both, a -1 in both, a 0 in both, and a 1 in both. So that's going to go into the middle. That has effectively answered our question. So you can stop here, but just so you get a sense of it, I'm going to keep going. So 1, and there are 4 things, or 4 elements that are in the intersection. What's left to go in C is -3, 2, 3, 4, 5, 6, 7, 8, and 9. There's nothing left to go in D. So actually D is a subset of C. How we would write that with our sets notation is D is contained in C. So they wanted us to list the elements of C intersection D, and that is -2, -1, 0, and 1. So example 9. Describe the sets indicated by the shading area in each of the following Venn diagrams. So in part I, all of A, all of B, and all of C are shaded. So this is A union B union C. In part II, it's the intersection of all 3 sets, meaning it is A intersection B intersection C. In part 3, if you ignore the circle B, so imagine that set B wasn't there, that's simply the intersection between A and C. So the answer is A intersection C. Now these are all commutative, which means we can write them in whatever order you like. I like writing them in alphabetical order, but for example, the last one, if you wrote C intersection A, it is the correct answer. Example 10. Use the symbols union, intersection, complement, and the backslash, which means less or difference, to describe each of the following shaded areas. So the first one, it is all 3 circles highlighted, but the centerpiece taken away. So we would write this as A union B union C, but we've taken away the intersection of all 3 sets. This looks like A union B union C less A intersection B intersection C. Part 2. Now we have the whole universal set, but we have taken away B union C. So that's one way we can write it. It is the universal set less B union C. Now, there is a second way you could write this, and that is it is B union C complement. So it's the opposite of B union C. So it's B union C, but then do the opposite. Example 11, identifying regions. Shade the region that represents each of the following sets. So in the first one, we're going to do A intersection B. So A intersection B is this piece here. We ignore C, doesn't get involved. This is A intersection B. In our second one, so I'll label that one. In our second one, we do A intersection B less C. So here is A intersection B, but then we take away anything that's in C, which just leaves us with this piece here. Now, the third part, A less B union C. So let's shade in A first. So this is A. And we take away B union C. So we take away all of B and C combined, which leaves us just with that section there, and we can tidy that up a little bit. So that is A less B union C. And the fourth and final part is B intersection C, take away A. So B intersection C is here and here. And now we take away A and we're left with just this piece here. Okay, so that is B intersection C less A. Example 12, properties of sets. So you would have learned about the properties of numbers, and these can also be used to describe sets. So we have three properties we know about. That is commutative. Usually we talk about adding and multiplication being commutative. It means the order doesn't matter. So 2 multiplied by 3 is the same as 3 multiplied by 2. We then have the associative property, which means you can associate any numbers together. So for example, if I had 2 by 3 by 4, it doesn't matter which two numbers you multiply together first and then multiply your answer by the last. The last one we have is distributive. Now this property you are probably most familiar with in algebra, because when we multiply out a bracket, we're using the distributive property. So here we have six little equations, and we need to put a property beside each. So A union B is the same as B union A. That's the same as 2 by 3 is the same as 3 by 2. So this is the commutative property. Part 2. A intersection B intersection C is the same as A intersection B intersection C. So it doesn't matter which two you do first. This is the associative property. Part 3 is another version of the associative property, but this time it's for union. In part 2, it was for intersection. Here we have A intersection B union C is the same as A intersection B union A intersection C. This is like multiplying out a bracket, A by B, A by C, and the sign will be in the middle. So this is called the distributive property. Part 5, A union B intersection C is the same as A union B intersection A union C. This is the distributive property. And finally, A less B less C is not the same as A less B less C. So they're trying to show the associative property, but it's not valid. It's like subtraction, and it will matter, or division will matter what we do first. So this shows that it's not associative. Problem solving with Venn diagrams. Venn diagrams are a great way to visually display data, and up to now we've used each Venn diagram to show the individual elements, and we do this using a dot. However, if there's a very large number of elements, this method would take too long, it's too confusing, it's too hard to fill in. So instead, we can fill in a Venn diagram with the cardinal number, i.e. the number of elements. We do this without a dot. So example 13. In a survey of 40 households, 22 had a dog, 16 had a cat. If 8 households had both cats and dogs, represent this information on a Venn diagram. Okay, so the first thing we're going to do is we fill in a Venn diagram from the center. So we know that 8 households had a cat and a dog. I'm going to cross this off as I use it. Now, I don't put a dot because that is not the number 8 as an element. That represents there are 8 household names that should go there. But this is just an easier way to work it. There are 22, and we can use little square brackets to help us here. So there are 22, oh, I've gone the wrong way. So there's 22 households that have dogs. We've already filled in 8. So we need to figure out how many are left that only have a dog. So this section here is the section where there's only a dog, and that leaves us 14. The combined circle should still add to 22. There are 16 households that have cats. 8 is already filled in, leaving us 8 out here. Now, we just want to do a quick double check. We have 8 plus 8 plus 14. So that's 30. But there were 40 households. We've used 22, we've used 16. There were 40 households. So there's 10 households not missing. Or there's 10 households not counted. There are 10 households that are missing. And they will appear in the Venn diagram as not having a cat, not having a dog. They are out here in the universal set of households that were surveyed, but don't have an animal. So example 14 then, here's another version. In a survey of 80 people, 56 watched RTE on the previous night, 34 had watched TV3. Okay, if 22 people watched neither of these stations, how many people watched both? Okay, so the first thing we're going to do is look at the fact we have RTE and TV3. Okay, so I'm going to call this set A, and I'm going to call this B. Well, actually, it'd probably be better for me to use R and T. So there's RTE and there is TV3. 22 people watched neither. So we have 56 watched RTE, 34 watched TV3, and then neither, so 22 watched neither. When we add all these numbers up, so 56 plus 34 plus 22, we get 112. Now that's interesting because we only actually asked 80 people. So the extra people there, and there are 32 extra people. Why is there 32 extra people? If we only asked 80, why do we get 112 responses? Well, we don't, but those 32 extras, they're the people that watched RTE and watched TV3 and then were double counted. So that extra amount goes in here and it gives us the intersection because they were double counted. So I've used my 80, I've used my 22, RTE there were 56. So I've already put in 32, so that means there's 24 left. TV3, there was 34. We have 32 there, which means there's only 2 left. And if we have 24 plus 32 plus 2 plus 22, that is 80. So how many people watched both? And the answer is 32. So when you have a problem like this, and it's not adding up because there are too many people compared to how many were asked, those extra were in the middle because they were double counted. So now let's look at problem solving, but here they've given it in a slightly different way. They've given it as the cardinal numbers. So fill in the number of elements in each of the regions. So remember, first place we go is intersection. But there is an issue. We weren't given the intersection. We need to work that out. Okay, so the first thing I'm going to do is, well, A has 21, B has 16. So if we add those two together, 21 plus 16, that's 37. Now, A union B combined should only have 30. So if A has 21 and B has 16, combined they have 37, but only 30 people should be included in that, we have 7 extra. Those 7 extra, they go in here in the center. So I have 14 left here. I have 9 left here. If I add that up, I get 30. My universal set was 43. So if I have 30 included here, there are 13 people who sit outside set A and set B. So now they ask, what is the cardinal number of A intersection B? And that's this number here. So the answer is 7. What is the cardinal number of B take away A? So it just leaves me this bit here because the whole circle of A is gone. So that leaves me with 9. And then A union B complement. So the opposite of A union B. So everything that's not A union B, which is everything outside of it, which is 13. So we're just looking at this number here. So now let's look at problem solving with 3 sets. So we have in this question 3 different languages, French, English, and German. So here's my universal set, and I'm going to set these up at French, English, and German. Now, 85 students study French, 60 study English, 25 study German. These are totals. And I'm going to put them outside because I don't know how to fill them in. I know the whole circle should add to this, but I need to know more of a breakdown on the sections. So if 18 study both French and English, and 10 study both French and German, 8 study both English and German, and 5 study all 3 languages. Illustrate this on a Venn diagram. Remember, we always start from the innermost part. So here we want to know what all 3. How many people study all 3, which is like the last statement we were given. So I'm going to cross that off. Well, actually, you should see it first. It's 5 study all 3, and we'll take that. So 5 goes in here. So often with these questions, especially how we've seen them asked in the junior cert exams, we would generally work from the bottom up. So the last piece of information is usually the first piece we fill in. So 8 study both English and German. Now, that 8 belongs all of this, okay, because it's English and German. We've already put in a 5. So we're only putting in what's remaining, and that's the 3. 10 study French and German, but 5 is already in, so we only place a 5 in this part. And 18 study both French and English. We already have 5 in, so we're only putting in 13 here. Now we're able to use the fact of 85, 60, and 25 to figure out what goes in each of the sections. So for French, we have 85 in total, but we've already filled in 13, 5, and 5. So that's 23. So taking away 23 leaves us with 62. For English, there's 60 in total, but we've already filled in 13, 5, and 3. So taking those away leaves us with 39. For the German circle, the whole circle should add to 25. We've already included 5, 5, and 3. We've already included 13. So 25, take away 13, and we are left with 12. Now, is there anything outside of this? Well, they said in a language school, all students attending study 1 or more of the 3 languages. Okay, so we've filled in our Venn diagram, and we now need to find it, to use it to find how many students attend the school. So we're going to add all of these together. Just be careful, there's so many numbers not to double count anything. So that is my full French circle, plus adding in what was extra there for English, plus then a 12. Notice how there is 4, 5, 6, 7 sections, so we should have 7 numbers. So we have 62 plus 13 plus 5 plus 5 plus 39 plus 3 plus 12. So there were a total of 139 students. Part 2. How many students study one language only. Well, 62 study only French, okay? And we're getting that from here. This section is only French. We have 39 study only English and 12 study only German. So only means there is just German, just French, just English, so no intersections. The intersections represent where there is more than one subject. So these are 113 students. How many students study, let me get rid of this highlight. How many students study both English and French, but not German? Okay, so English and French is this whole piece here, but not German. So this is asking us in sets terms, F intersection E less G. So that's it. French and English and French, it's commutative, it doesn't matter what way you write it, less G. So we're taking away that G part. So we're getting rid of this bit, which leaves us with 13. So that's how we could be asked the same question we've been answering, but it's asked in words. Example 17. Now, this is kind of the hardest style of question that we meet, or at least have met in the junior certificate exams. It's 3-set problem solving, including an unknown. So including a variable. So we're going to have an X. So a survey was taken of a group of 44 students. So we're going to highlight all these key numbers. So 44 students, each of whom was studying one of the 3 subjects, history, geography, art. So here's my universal set. So I'm going to do history, geography, and art. 28 studied history. So I'm going to place that here to use later. 6 students studied history only. Now, I can actually fill that in because this section here means history only, because any of the other 3 sections are history and geography and art, history and art. So we've used that. 30 students studied geography. So there's my 30 to be used later. 15 studied both history and geography. Now, I need to leave this for a minute. I can't fill it in and there's nothing I can say, so I'm going to highlight that. 22 students studied art. So I'm going to place that here to use in a bit. And 3 students studied all 3 subjects. Okay, so we've used that. So there's 2 pieces of information we haven't used. So use a Venn diagram to find the number of students who studied history and geography, but not art. So actually, they want us to figure this part here. History, geography, but not art. How many students studied history and art, but not geography? So that's the second part. They want us to find this piece here. Okay, I should start color coding these. So that's the answer to part I. And find the number of students who studied geography only. Okay, so here is geography only. We want this part here. It gives us a hint. Let X represent the number of students who studied geography and art, but not history. So they've given us a big hint here and told us to fill this in as X. Okay, so I'm going to go back to the thing we've highlighted. So 15 students studied both history and geography. So this whole section here should add to 15. I already have 3 in, so 12 is there, which is my answer then to part I. So this is good. I suppose in an exam, the questions are broken out a little bit better, but this is a good way to approach if there's a few things to do. How many students studied history, art, but not geography? So the green part. Well, remember, we know history has to add to 28. We have already filled in a 6, a 12, a 3. So we add in 21. So that means there is a 7 here. Okay, so then find the number of students who studied geography only. Now, what we can do for the two missing sections is write an expression in terms of x. So we have for art 7 and 3 and x already filled in. So we can do 22 take away 10x. No, 10 plus x. 10 plus x. So focus on the numbers and we'll get 12 take away x. Okay, so there was 22 in total. We've already filled in this part. Taking that away gives me 12 minus x. We can do something similar here. We get 15 minus x. So 30, take away 12, take away 3, and take away x. Now, we know that all of them have to study one or more. So there's nobody outside of history, geography, and art. And we know that this whole thing should add up to 44. So now let's create an equation. So the whole the whole history circle is filled in. So that is 28 plus. So we filled in the whole history part. Then we have 15 minus x plus x. That's fills in the whole of geography, plus 12 minus x. And when we add all that together, it should equal 44, which is what we were told the total was at the start. Get rid of these two x's. So we have 28 plus 15 plus 12. That gives me 55. Take away x equals 44. Take away 55 from both sides. So 44 minus 55 gives me minus 11. So x equals 11. So then if we want to figure out the number who studied geography only, it's going to be 15 minus x, which gives us 4. So you can go back and fill in the sections. So 12 minus 11, this is now 1. This is now 11. And this is now 4.